We are going to start now the next chapter, chapter 13 of class 10th mathematics. It is volumes and surface area of solids. So this is our first lecture. In our previous class, in class 9th, you have already studied the formulas for the volume and surface area of certain solids like cube, cuboid, cylinder, cone, sphere. The formulas you have already studied. So first of all, we are going to recall the basic formulas. So first is solids definition is given over here. So it is the objects having definite shape and size are called solids, and a solid occupies a definite space. Next we have the first solid figure we are talking about. It is the cuboid. So we have given some examples over here. We are saying the matchbox, chalk box, a tile, a book, an almirah, a room. All these are examples of a cuboid. So cuboid has, we are saying, 6 faces. Faces means if we are talking about the room, so it has 4 walls. One is the floor and one is the roof. So there are total 6 faces we are talking about. So if the length, breadth and height, these are shown over here. This is the length. If we are talking about a room, then one wall we are saying with one wall we are measuring the length. In another wall we are measuring the breadth on the base. With the floor we are saying, wherever the floor and the wall they are meeting, we are saying we are measuring on one side it is length, on other side it is the breadth, and between the two walls we are saying the length. When we are measuring this height, we are measuring it is the height of this cuboid. So when we are talking about the volume, these are the formulas that we have already studied. So it is length into breadth into height. So how we have calculated the volume? We are saying the base. When we are talking about, this is the base we are talking about. This base is the area of this base. First of all, it is cuboid, so we are drawing the base in this form. The length of this base, it is L, and breadth of this base, it is B, and we are saying we are calculating now the volume. So to calculate the volume, what we have done, we have multiplied this value with the value, this height is over here h, so we have multiplied length into breadth into height. This complete value will give us the value of the volume. So volume is basically, we are saying, it is the base area. This is base area into height. This is not always the case, because when we are saying base area into height, this is always the case, but in this particular case height is same at every point. You consider any point over here, the height is same, so we are just multiplying it with h. So we are saying volume is length into breadth into height. Next is total surface area. So we have seen there are total 6 faces, 4 are the walls. So what are the area of the wall? You suppose I am talking about this wall over here, this wall. Then the area, the length of this wall, it is L, and height of this wall, it is h. So we are saying L into h. This is the area of this wall. Similarly, we are talking about this front wall. It is L into h. This is the area of the front wall. This is the area of these two walls. Next, we are talking about the walls on this side and wall on this side. So area of these two walls, it is breadth into height, plus there are two walls, so it is breadth into height. So what we get is, it is 2 times breadth into height. This is 2 times length into height. Next we are saying we have this base over here, so it is length into breadth, and this is the roof we are talking about, so it is length into breadth. So the answer we are getting for these two values when we calculate is 2 times length into breadth. So the final answer we are getting, the total area of this, it is 2 times length into breadth plus breadth into height plus length into height. This is the total area, and the unit for area we have, it is square units. The units for volume we have, they are cubic units. Area units for square, it is square units. Next we are saying lateral surface area. Lateral surface area means we are just talking about the area of the 4 walls. If I am talking about the room, I am talking about area of the 4 walls. And we are seeing over here the area of the 4, the base and the floor, it is 2 times length into breadth. So we are not considering this length into breadth in the formula, and whatever the remaining value is, we are writing it is the area, lateral area. So lateral area basically means that we are not considering the base and the top part, we are just considering the 4 walls. So that is the lateral surface area. Next is the length of the diagonal. So when we are talking about diagonal means this point is over here and this point is over here. We are joining these 2 points. When we are joining these 2 points, we are saying the length we are obtaining, it is the diagonal. So to calculate this length, we are saying first of all we are considering this base part over here, this base over here. This figure is shown in this form, but all these angles, these are of measure 90 degree. Now if I draw the diagonal for this rectangle on the base, this is a rectangle on the base, I draw a diagonal over here. The length of this diagonal will be, and this part is L, this part is B, so it is square root of L square, square root of L square plus B square. Next we are considering this triangle over here. We are talking about this triangle. I am again marking this triangle over here. This triangle we are talking about. This triangle we are saying. So in this triangle, we want to calculate the length of this side, it is H. Length of this side, it is this. So I am drawing it again over here. We are having, this is the base, this is the right angle, and this side is over here. This side we have obtained, this value is square root of L square plus B square. This value is H. So what we will get, the length of the diagonal will be square root of L square plus B square plus H square units. One important thing to note over here, when we are talking about the diagonal, it is just the length. So we are writing it is units, it is meter, centimeter, whatever value we have. Next we are talking about it is lateral surface area. So when we are saying lateral surface area, it is square units. The units we are writing, it is square units. So it should be centimeter square, it should be meter square. All these values are there. When we are talking about the volume, it is cubic units. So it is cc, or we are we can write the units may be in liters, or it may be meter cube. So these all units, these are the cubic units, these are the units for the volume. Now the next figure we are talking about, it is cube. So cube is a cuboid which has all 3 sides equal. So we are saying length, breadth and height, all these 3, these are equal to A. It is shown in the figure that length, breadth and height, these are equal to A. So the volume for the cuboid, it was length into breadth into height. All these values are equal to A, so we get it is A cube. Total surface area means surface area of all the 6 faces. In case of cuboid, the formula is 2 times length into breadth plus breadth into height plus height into length. In this case, all these values are equal, so we get the answer is 6 times A square. So we are saying A square is the area of one face of this cube, and 6 times means there are total 6 faces. Next we are saying is the lateral surface area. Lateral surface area means area of the 4 walls. So the formula we have, it is 2 times breadth into height plus length into height, or we are writing it is 2 times height into length plus breadth. So when we substitute this value, we are saying there are now total 4 faces. So the answer we get it is 4 times A square. And last we are talking about the diagonal. So to calculate the diagonal, what we have done, we have joined these 2 points first. We are considering this triangle. We are considering this triangle. We are saying this side is A, this side is A. So this side will be root 2A. Next, when we are talking about the diagonal, we are joining this point with this point, and we are considering this triangle over here. We are considering this triangle. This height we are saying this is equal to A. This side we are saying it is A square root 2. So what we get is that this side over here, when we will calculate the value, we will get the answer is square root of root 2A square plus A square. It comes out to be 2A square plus A square, that is equal to root 3A. This is the value of the length of the diagonal. Now the next figure we are talking about, it is the cylinder. So we are saying the example is given over here for the cylinder. It is the measuring jars we have, the circular pillars we have, circular pencils we have, circular pipes, road rollers, gas cylinder. These are all having the shape of a cylinder. So for the cylinder we are saying we have the base radius is there. This value we are saying this is the base radius, and this is the height h we are writing. We write it is height h. So the volume of the cylinder when we are calculating, we are saying how many faces you can say, or one is this base. Area for this base, this is circular base, radius of this base it is r, so area of this base will be pi r square. When we are talking about this upper portion, we are saying the area of this part it is pi r square. If we have to calculate the volume of this cylinder, what we are going to do is, we are saying this is the base for this cylinder. At each point over here, we are talking about each point over here, the height we have it is h. You consider any point over here, the height that we have at any point from the base, it is h. So we are saying the volume we can calculate using the formula, it is base area into height. So base area we have it is pi r square and height it is h, so it is pi r square h. This is the formula for the volume of the cylinder. Now the next we have is the curved surface area. Curved surface area is again, we are saying the area of this boundary. We are not considering the area of this top part and this bottom part. We are just considering the boundary of this cylinder. So to calculate this area, suppose we are saying we cut this cylinder along the height at some point, and we open this and make it a straight on. We open it and make it straight like this, so it will become a rectangle. The breadth of this rectangle will be the height. We have cut it from this part, we have opened it like this. From these two places we have opened it and made it straight. All the edges we have made it straight. Now what is the value of length of this part? It is the circumference of this circle, it is 2 pi r, and this 2 pi r is basically now the 2 pi r is now the length of this rectangle. So the total area of this rectangle will become 2 pi r h, and this is the curved surface area of this cylinder we are saying. Next is total surface area. We have the value of curved surface area, it is 2 pi r h. We are adding to it two values. One is pi r square, this is the area of the top portion. This is pi r square, this is the area of the bottom portion. So the total area we will have now, it is 2 pi r h plus 2 pi r square, and the answer we will get it is 2 pi r into r plus h. This is the total surface area of this cylinder. The next definition we have, it is hollow cylinders. So we have given examples over here. We are saying the solids like iron pipes, we are talking about rubber tubes, we are talking about the shapes like this. The iron pipe is there. It is hollow cylinder, means that the pipe is in this form. We have some boundary over here. The boundary for this pipe is there. So what are the kind of boundaries we have? We are saying on this side, if we look at this portion of this pipe, it will be just like a circular ring. This portion of the pipe, it will be circular ring. Suppose its inner radius we have, it is small r, and the outer radius we are talking about, it is capital R. So this area we are talking about, if we want to calculate this area, the area of this portion, that will be pi of capital R square minus small r square. How much such portions will be there? There are two portions, on this side of the pipe and on this side of the pipe. Or we are saying this, in place of pipe we are using, in general we are talking about, so it is hollow cylinder we are talking about. So the first thing we have is that the height we are talking about, it is same at each point. This is the base of the cylinder, suppose, then the height at each point it is same. We are talking about the inner radius, it is small r, and the outer radius over here, it is capital R. Now if we want to calculate the volume of the material used to make this cylinder, it is hollow from inside. The cylindrical portion is only on, this is the portion we are saying of which cylinder is made of. It is hollow from inside. So when we are talking about the volume of this material, so the volume will be pi capital R square h, this is the volume of the outer portion, minus pi small r square h, this is the volume of the inner portion. So pi h is common and we are left with this capital R square minus small r square. So this is the volume of the material used, or volume of the material of this cylinder. Second thing, we have it curved surface area of the hollow cylinder. So there are two portions again. One is the inside portion. So for inside portion, when we are talking about this inner portion over here, we are saying the area we have, it is 2 pi small r h. And for this outer portion, the area we have, it is 2 pi capital R square h. This is the lateral area of these cylinders. The inside portion, this is for the outer region. And when we are talking about the total surface area of the hollow cylinder, how many cylindric circular portions are there? Two more circular portions are there. So we get the answer is 2 pi r h. This is the area of the inner part. 2 pi capital R square h. This is the area of the outer part. Next we have plus pi times R square minus capital R square. This is the area of the bottom part. We are multiplying it with 2 because we have another portion over here, that is this upper portion or cover we are talking about. So when we solve this value, suppose we are writing 2 pi common from this, we are left with this r h plus r square h plus r minus r into r plus r. So it is 2 pi into h is common, so it is r plus r square. It is not r square over here, it is r over here. So we are left with this r plus r minus capital R minus small r into capital R plus small r. Now if we take r plus r common from both these terms, so answer we are left with this, the formula we are left with is 2 pi capital R plus small r into h plus r minus r. You need not to remember these formulas, you can just remember the basic formulas and you can understand how the cylinder is formed. I think when we are talking about this portion, this is the lateral area of inside cylinder plus outside cylinder plus 2 circular rings. You can just remember this part. You need not to remember each formula separately. Next we have is cone. So we have in our previous class, we have already studied that cone means we are talking about ice cream cones, maybe the example, conical tents are there, funnels are there. These are some examples of the conical shapes. And when we are talking about a cone, we are saying we are having a circle over here. The radius of this circle, it is r. Next term we have over here, it is the height. This is the height of this cone. And the next term we have, it is this height L. This L, it is called the slant height. This is the height of the cone and this is the slant height of the cone. So if we are talking about the volume of the cone, how we have justified this formula 1 by 3 pi r square h? We are justifying it in the form, suppose we have a cylinder and we have a cone. We are saying the radius of both these, it is say small r, and height for both these, this height we are talking about, it is h. Then suppose we fill this cone with water or with some liquid and we transfer this liquid to this cylinder. We are saying we require 3 such cones to fill this cylinder completely. So what we get is, we are transferring the water, so the volume of the water we have over here, we are talking about the cone, so we are writing it is V cone. So we are saying 3 times the volume of cone, that is equal to the volume of, suppose this cylinder we are writing, it is volume of cylinder. So we get that the volume of cone we have, it is equal to 1 by 3 times volume of cylinder. We require 3 full cones to fill this cylinder. And the formula for the volume of cylinder we have, it is pi r square h. So the volume of the cone that we will have, it is 1 by 3 pi r square h. Next, we are saying what is slant height? It is, this is the right angle. We are talking about the right circular cone. Circular means this is the circle. This is the right angle. So these kind of cone, these are called the right circular cone. And this value of L we will get, it is equal to square root of h square plus r square. Now the curved surface area of the cone, when we are saying to calculate the curved surface area, means we are talking about only this boundary part over here. So we are saying if we cut this cone from this point and we open this cone, then the value of this area, the curved surface area, the shape that we will get, the value of that area will be pi r L. So how we are getting this formula is, when we open this portion of the cone, we will get some figure in this form. This length will be L, this angle will be theta. So when we calculate the area of this sector we are talking about, that will give us the area, the literal area of this cone, and the answer you will get, that is pi r L, and the value of L we are saying it is square root of h square plus r square. Next formula we have, it is total surface area of the cone. So for total surface area, we are saying to the literal surface area, we are adding the area of this base. The area of the base we have, it is pi r square. We are adding the area of this base to this area of the cone, and the answer we are getting, we are writing pi r common, it is L plus r square units. So this is the volume, total surface area of the cone, and this is the lateral surface area of the cone. The next solid objects we have already studied the formula. It is sphere and hemisphere. So sphere, we are saying the objects of the shape of, examples are given over here. We are talking about a football, a cricket ball, all these have the shape of a sphere. And we are talking about if the radius is given to us, then these are the formulas. Volume of the sphere, it is given by 4 by 3 pi r cube, and the surface area of the sphere, it is given by 4 pi r square units. Next is hemisphere. Hemisphere means half. We have cut the sphere from the half, so volume will become half, and the formula that we will get, it is for volume of the sphere, we are saying it is the volume we have, it is 4 by 3 pi r cube. So the volume we have, it is 1 by 2 into 4 by 3 pi r cube. So it is 2 get cancelled, and we are left with is the volume of the hemisphere is 2 by 3 pi r cube. When we are talking about the curved surface area of the hemisphere, curved surface area means we are considering this portion of the hemisphere, and we are talking about the area of this portion. So the area will be, the area of this portion, that will be half the surface area, the total surface area. So that will be 2 pi r square. When we are talking about the total surface area of the hemisphere, we are talking about this portion also, this upper portion we are talking about, and this is a circle of radius r, so its area is pi r square. So total area of this hemisphere, that is 3 pi r square. This is the total surface area of the hemisphere. Next we have spherical shell. So spherical shell we are talking about, just like the hollow cylinder we are saying. Spherical shell means that this is the, just you can say it is hollow sphere or hollow hemisphere we are talking about. If I am talking about a hemisphere, it will be of this form. If I am talking about a sphere, it is, we are saying it is of this form, that it is hollow from inside. Only this much portion is the solid portion. Only this much portion over here, it is the solid portion, and it is hollow from inside. So when we are talking about the volume of the hollow sphere, so we are saying the volume of this outer portion, it is 4 by 3. So the radius, it is capital R, inner radius, it is small r. So it is 4 by 3 pi r cube, and the volume of the inner portion we have, it is 4 by 3 pi small r cube. So the volume of this portion, it is 4 by 3 pi capital R cube minus small r cube. This is the volume of the material used. If we are talking about the hemisphere, we are saying the volume of this portion we are calculating, so we can use corresponding formula. That is, if we are saying that this is the whole sphere and we cut it from this point, it will become a hemisphere. So the volume of this hemisphere will become half this value. This is the volume of this hemisphere. Next, we have some problems based upon the volume and surface area of combination of solids. And the first question we have is that 3 cubes each of volume 216 cubic centimeter are joined end to end to form a cuboid. We are saying we have 3 cubes. These are shown in the figure. This is the first cube, this is the second cube, and this is the third cube. These 3 cubes, these are joined end to end to form a cuboid. So volume of each of these cubes is given, so we can calculate the side of each cube. Suppose the side of each cube, it is a, then we will have a cube. This is the volume of the cube, that is equal to 216. So the value of a we will get, it is 6 centimeters. So we are saying that the length, breadth and height of each of these cubes, it is 6 centimeters. When these are joined end to end, the total length we have, it will be 18 centimeter, breadth will be 6 centimeter and height will be 6 centimeter. This thing is clear from this figure. So we have to calculate the total surface area of the resulting cuboid, and this becomes a cuboid. Length, breadth and height are given to us, and the formula for total surface area, we know it is 2 times length into breadth plus breadth into height plus height in length into height. We substitute these values over here. Length into breadth means 18 into 6. Next, breadth into height means 6 into 6. Next is length into height, it is 18 into 6. And on solving this, we will get the answer is 504 centimeter square. Now the next question we have is, a sphere and a cube have equal surface areas. You know the formula for the area of the sphere. It is 4 pi r square. And suppose the side of the cube, it is a. So the total surface area of the cube, it is 6a square. So it is given that 4 pi r square, that is equal to 6a square. We have to show that their volumes are in the ratio root 6 is to square root pi. So when we are talking about the volume of sphere over volume of the cube, the formulas we have for volume of sphere, we have 4 by 3 pi r cube, and for the volume of sphere we have, it is a cube. Now we have to calculate the value of, this is 4 by 3 pi r by a cube. Now from this first equation, we have r square over a square equal to 6 by 4 pi, and this gives us r over a is equal to 6 by 4 pi raised to the power 1 by 2. Now if we substitute this value over here in this equation, we'll get it is 4 by 3 pi r by a square into r by a. We can write it in this form. So we will get it is 4 by 3 pi into r by a square, it is 6 over 4 pi, and r by a value, it is 6 over 4 pi raised to the power 1 by 2. So on solving this 4 pi and 4 pi gets cancelled. We are left with 2 over here. So the ratio we are getting from this 4 is there, and square root of 4, it is 2 comes out. This 2 also gets cancelled. So we are left with this 6 over pi square root, that is equal to root 6 by root pi. So the answer we are obtaining that the ratio is root 6 is to root pi. Next is a vessel is in the form of a hemispherical bowl mounted by a hollow cylinder. So we are saying this is a hemispherical bowl. This bowl we are talking about, and it is mounted by a hollow cylinder. This is the cylinder we are saying. This is the hollow cylinder. It is lying on this hemispherical bowl. The diameter of the hemisphere is 14 centimeter. It means the radius over here, this is 7 centimeter, and the total height of the vessel is given to be 13 centimeters. We have to find the capacity of the vessel. Number 2, the inner surface area of the vessel. So capacity of the vessel means we have to calculate the volume of this cylinder and we have to calculate the volume of this hemispherical vessel. So volume of cylinder, we know the formula is pi r square h, and for the volume of this hemispherical vessel, the formula we have, it is 2 by 3 pi r cube. It is hemisphere, that is why it is 2 by 3 pi r cube. For sphere it is 4 by 3 pi r cube. So the values we have over here, it is when the total volume we will have, it is sum of these two. If we take pi common, the radius is same 7 centimeter for both of these, so we are adding r square common. So from first we are left with h, and for second term we are left with 2 by 3 times r. So if we substitute these values over here, we will get it is 22 by 7 into the value of r square will be 7 into 7. The value of h will be the height. This h we are talking about, this is height of the cylinder. This is the total height 13 centimeter. This much portion is 7 centimeter. So the height of this cylinder, that will be 13 minus 7 is equal to 6 centimeters. So we are saying it is 6 plus 2 by 3 into the radius we have, it is 7. So the answer we are getting, it is this, these two 7 get cancelled. So the answer we are left with is 22 into 7, then it is 18 plus 14 by 3. On solving this, the final value that we will get, it is, this is given over here, it is 1642.67 centimeter cube. Centimeter cube is the unit for the volume. So this is the total volume of this vessel. Next thing we have to calculate is the inner surface area of this vessel. So inner surface area means we are talking about, again we have two figures over here. One is this hemisphere. So the surface, inner surface area of this hemisphere, it is 2 pi r square. The total surface area of the sphere is 4 pi r square, and the hemisphere, for hemisphere when we are talking about the inner surface area, that will be 2 pi r square. And the inner surface area for this cylinder, the formula we have over here for this cylinder, the inner surface area we have, it is plus 2 pi r h. If we substitute the values over here, we are saying it is 2 into 22 by 7 into the value of radius we have, it is 7 into 7 plus height over here, it is 6. These two 7 gets cancelled, so we are left with this 2 into 22 into 30. And on solving this, the answer you will get, it is 572 centimeter square. Next is, due to some floods, some welfare associations jointly requested the government to get 100 tents fixed immediately and offer to contribute 50% of the cost. If the lower part of each tent is of the form of a cylinder of diameter 4.2 meters, this is the lower portion we are talking about, it is a cylinder, and the diameter of this portion is given to be 4.2 meter. So the radius that we will have over here, that will be 2.1 meter, because diameter is 4.2 and height is 4 meter. For this cylindrical part, the height is 4 meter, and the conical upper part of the same diameter, the upper part is this cone we are talking about. This is the conical part. It has the same diameter as that of the cylinder, and its radius is 2.1 meter. and the height is 2.8 meter. This is the height given, it is 2.8 meter. The cost of the canvas used for the tent, it is rupees 100 per square meter. So when we are talking about the cost of canvas, so what we have is the canvas will be used to make this cone, the literal area of this cone, or we are saying sides of this cone, because it will be hollow from this side. Similarly, this tent will be hollow from this side. So what we require is, we require lateral area of cone plus cylinder, plus this cylinder, and the formula for the lateral area of cone we know, it is pi r l, and the formula for the lateral area of the cylinder we have, it is 2 pi r h. This is the lateral area of the cylinder. When we are looking at this value L means we are talking about, this is the slant height. We are saying L is equal to square root of 2.8 square plus 2.1 square, and on solving these values we get the square of this value, it is square root of 4.41 plus 7.84, it is square root of 12.25, and on solving this square root, the answer you will get, it is 3.5 meter. This is the square root of this value. So this is the slant height. So the answer we will have for the area, we substitute these values in this formula. So we get, it is 22 by 7 into 2.1 into 3.5. This is the value of pi RL plus 2 into 22 by 7 into the radius we have, it is 2.1, and height we have, it is 3.5. On solving these values we will get, it is 52.8 plus 23.1, and the answer we will get, it is 75.9 meter square. So this is the total area of the canvas that is required to make this tent. Next we are saying, we are given over here that the cost is rupees 100 per square meter. So 1 square meter, the cost is rupees 100. Now how many square meters we require? The canvas, it is 75.9 meter square we require. So the total cost will be 7590 meter square. So this is the cost for one tent. Next, how many tents we require? We require 100 tents, and it is given that the 50% of the amount that will be given by the government. So the total cost for the 100 tents, when we are talking about 100 tents, the total cost will be 759000 rupees. This is the total cost for the 100 tents. Now we are saying that 50% will be contributed by the government. So association will have to pay 50% of this value. The calculation, these are shown on our next slide. We are saying the total cost we have, it is 75900. Now 50% is to be paid by association. So it is the 50% of this value, means we are saying it is 50 by 100 into 75900. On solving this, the value comes out to be 379500. So we are saying this amount is to be paid by the association. Now the next we have is, what values are shown by these associations. So the values shown are, we are saying help the people in need, or donate a part of our income to charity, or it is join hands together for a noble cause like community service. These are the values shown by these associations which help the needy people. Next is a cylindrical tub of radius 5 cm and length 9.8 cm is full of water. So this is the tub given to us. The radius of this tub, it is 5 cm, and the length of this tub, it is 9.8 cm, and it is full of water. A solid in the form of right circular cone mounted on a hemisphere is immersed into the tub. we are saying this is the solid we are talking about. It is it has hemispherical base and it is having a right circular cone mounted on the hemisphere, and it is immersed in this tub. The radius of the hemisphere, this radius is given to be 3.5 centimeter, and the total height of this solid, it is given to be 8.5 centimeter. It means the height of this cone, it is 8.5 minus 3.5 is equal to 5 centimeters. And now what we have to find is, we have to find the volume of the water left in the tub. So we are saying that this cylinder is there. Suppose it is full of water. When we immerse this solid in this cylinder, some water will come out. Some water will come out and some will be left over here. So basically we are talking about the quantity of water in the cylinder. So when we are talking about quantity of water in the cylinder, it means we are talking about the volume of cylinder. We are talking about volume of cylinder. Now, to calculate the volume of the water left means, first of all we have to calculate the total amount of water in the cylinder. So that will be equal to the volume of cylinder. Next, we are saying how much is the volume of this object. Volume of object. If we subtract these two values, we will get the amount of water left, because the amount of the water displaced will be equal to the volume of the object. Now the formula for the volume of the cylinder, it is pi r square h, and volume of this object, it is made up of two things. One is this hemisphere and one is this cone. The volume for the cone is 1 by 3 pi r square h. The radius is also different, so we are writing it as, say, capital R square h, plus the formula for the volume of this sphere, hemisphere we are talking about, so it is 2 by 3 pi r cube. When we subtract these values, these two values, when we subtract, we will get the volume of the water displaced. So we are writing the volume of the water displaced will be pi r square h minus 1 by 3 pi capital R square h plus 2 by 3 pi capital R cube. So the answer we will get, it is 22 by 7 into, it is radius of the cylinder, it is 5 into 5 into 9.8. This is the volume of this cylinder. Then it is minus 1 by 3 into 22 by 7 into the radius. Now we have it is 3.5 square into height we have over here for this cone, it is 5 centimeter. Then it is plus 2 by 3 pi, the radius for this hemisphere, it is 3.5 and it is cube over here. So when we solve these values, these calculations are shown over here. When we multiply these values, this is the volume of the cylinder that we will get. This is the volume of the cylinder, and on solving these two values, these are the two values we are talking about. On solving these two values, we get 154 centimeter cube is the volume of this object. So volume of the water left in the tub, that will be the difference of these two values, and it comes out to be 770 minus 154, that is equal to 616 centimeter cube. Next we have is a solid wooden toys in the form of a hemisphere surmounted by a cone of same radius. So we are saying this is the hemisphere we are talking about, and this is the cone on this hemisphere. The radius of the hemisphere is 3.5 centimeter. 3.5 centimeter, it is the radius of this hemisphere. It means this height over here, This is 3.5 centimeter. It is mentioned over here. And the total wood required or used in making the toy is 166 hole 5 by 6 centimeter cube. So this is the volume of the wood required to make this toy. It means it is the volume of this whole toy. We have to find the height of the toy. So we are saying, suppose the height of this portion, this conical portion, it is h. Then the volume of this cone, it is 1 by 3 pi r square h. And the volume of this sphere, hemisphere, we are saying, it is 2 by 3 pi r cube. And the total volume, it is given to be 166 5 by 6, and this comes out to be 1001 by 6 centimeter cube. Now if we substitute the known values in this, we will get it is 1 by 3 into pi into the value of r square, we have it is 3.5 square, plus 2 by 3 pi into the value of r is 3.5 square, it is 1001 by 6. We take 1 by 3 pi and 3.5 square common. So the answer we will get is cube over here and it is h over here. So when we take square common from this, we are left with, from the first term, we are talking about this term over here, what we are left with is, it is h. From the second term, this term we are talking about, from the second term we are left with is 2 into 3.5, and this value is equal to 1001 by 6. On solving this, this is h plus, this value will become h plus 7. Now we get h plus 7, that is equal to 1001 by 6 into 3 into 7 by 22 into 1 by 3.5 square. When we solve these values, the answer we will get, that is 13. So the value of h we will get, it is equal to 6 centimeter. So we get that the height of this cone we have, it is 6 centimeter. This is the height of this cone. Now the next thing we have to find is the cost of painting the hemispherical part of the toy at the rate of 10 rupees 10 per centimeter square. It means we have to calculate the area of this hemispherical part, and the formula for area we have, it is 2 pi r square. When we substitute the values in this formula, 2 pi r square, we will get the values in this form. It is 2 into 22 by 7 into the radius is 7 by 2 into 7 by 2, and the answer comes out to be 77 centimeter square. The cost is given to be rupees 10 per square centimeter. So the total cost of painting, that will be equal to 77 into 10, that is equal to 770 rupees. So this is total cost of painting the hemispherical part of the toy. Next we have is, a solid is in the shape of a cone mounted by a hemisphere. So again this figure is given to us, that a hemisphere is there and a cone is on this hemisphere, and it is given that the radius for both the cone and hemisphere, they are same if the curved surface area of the hemispherical part and the conical part are equal. So we are talking about the curved surface area of this conical part. The formula we have, it is pi rl, and the curved surface area for this hemisphere we have, it is 2 pi r square. The value of radius is same for both these. Then we have to find the ratio of the radius and height of the conical part. We have to find the ratio for r and h. So from these values, r is not equal to 0, so this r gets cancelled, this pi gets cancelled. So we are getting that L is equal to 2 times r, and the formula we know for h, it is square root of L square minus r square. If we substitute this value of L over here, we will get it is square root of 4r square minus r square, and the answer comes out to be root 3r. So the value we get is r over h. We have to find the ratio of radius and the height. So we are saying r over h, that is equal to 1 by square root 3. So the ratio we have, it is 1 is to square root 3. This is the required ratio. Now the next question we have is a solid cylinder of radius 12 centimeter and height 15 centimeter. So a cylinder is given to us. The radius of this cylinder, it is 6 centimeter, and height of this cylinder, it is 15 centimeter, and it is melted into 12 toys of shape of right circular cone. This is the cone mounted on a hemisphere. This is the hemisphere we have. We have to find the radius of the hemisphere and total height of the toy if the height of the cone is 3 times the radius. So if the radius of this cone we are considering it is r, it means the radius of this hemisphere is r, then it is given that the height of the cone is 3 times. So height of the cone we have, it is 3r. So we are saying this cylinder, it is melted in the form of 12 such toys. So the volume of this cylinder, we have the formula, it is pi r square, it is 6 square into 15 pi r square h, and the volume of this toy, it is volume of this sphere, volume of this hemisphere. Volume of the hemisphere means it is 2 by 3 pi r cube plus volume of this cone, and it is 1 by 3 pi r square, and height of this cone, it is 3r. Now it is given that how many such toys are there. There are number of toys, it is 12. 12 such toys are there. It means volume of 12 such toys, that should be equal to the volume of this cylinder. The pi gets cancelled from all these values. So what we are left with is that 6 into 6 into 15, that is equal to 2 by 3 r cube. This 12 comes on this side, plus 1 by 3. This 3 and 3 gets cancelled, and it is r cube. So that is equal to 5 by 3 r cube. So the value of r cube that we get, it is equal to 6 into 6 into 15 into 3 upon 12 into 5. These 2 gets cancelled, we are left with 3. These 2 gets cancelled, we are left with 2. These 2 gets cancelled, and we are left with 3. So the value of r that we get, that is equal to 3 centimeters. So we are saying the radius of this toy, that is equal to 3 centimeters, and the height of this toy, this r is 3, this 3r is 9. So total height of this toy, it is 4 into 3 centimeter, that is equal to 12 centimeters. Next we have is an iron pillar has some part in the form of a right circular cylinder and the remaining in the form of right circular cone. So it is given that some part is there which is in the form of right circular cylinder, and some part is there in the form of right circular cone. This upper part is there. The radius of the base of each of the cone and the cylinder is 8 centimeter. So this value is given that the radius of both is 8 centimeter. The cylindrical part is 240 centimeter high. This is the cylindrical part, and the conical part we have, it is 36 centimeter high. The height of this part, it is 36 centimeter. Find the weight of the pillar if 1 cubic centimeter of iron, it weighs 7.5 grams. It means we have to calculate the volume of this complete figure. So the volume of the conical part, it is 1 by 3 pi. Radius of this part, it is 8 square, and height, it is 36. And the volume of this cylindrical part, it is pi into radius is 8 square into height we have, it is 240. Now on solving this value, we will get the answer is, when you multiply all these value, it is these calculations are shown over here. It is 22 by 7, 8 into 8 into 240 into 1 by 3. So what we have done, we have taken pi common from both these values. It is 8 square common from both these values, and we are left with this 36 by 3 plus 240. On calculating these values, the answer we will get, it is 50688 centimeter cube. So this is the volume of this complete iron pillar. Now it is given that 1 cubic centimeter of iron weighs 7.5 grams. So the total volume now we have, it is 50688 centimeter cube. So the total weight for this much volume, it will be 50688 into 7.5, that is equal to 380160 grams. When we convert it to kgs, to convert to kg, we divide it with 1000. The answer we will get, it is 380.16 kg. This is the final answer that we will obtain for the weight of this pillar. Next we have is, a solid is composed of a cylinder with hemispherical ends. If the whole length of the solid is 104 centimeter and radius of each hemisphere is 7 centimeter. Now the complete length, it is given to be 104 centimeter. The radius of this hemispherical part, it is given to be 7 centimeter. The radius of this hemispherical part, it is given to be 7 centimeter. So the remaining portion we will have over here, that will be 90 centimeters. Now we have to find the cost of polishing the surface at the rate of rupees 10 per decimeter square. It means we have to find the surface area, the outer surface area of this solid. So for outer surface area, we are talking about the surface area, the lateral surface area of this sphere, hemisphere, the lateral surface area of this hemisphere. Both of these have radius 7 centimeter. So both of these combined, they will form a sphere. So the surface area for the sphere, the formula we have, it is 4 pi r square. It is 2 pi r square for this and 2 pi r square for this. So combined surface area, it is 4 pi r square. And the surface area of this cylinder we have, that will be equal to 2 pi r h. So the value we will, on substituting the values in this formula, we are saying if we take 2 pi r common, we are left with this 2 r plus h. So we substitute the values, we get 2 into 22 by 7 into radius, it is 7, then it is 14 plus height, it is 90. The sum, this complete sum, it is given to be 104. This whole value we are talking about, 90 plus 14, it is 104. This is already given to us. This is the total height over here. These two 7 gets cancelled. So the answer you will get, it is 2 into 22 into 104, and this comes out to be 4576 centimeter square. Now next we have is, we have to find the cost of polishing its surface at the rate of rupees 10 per decimeter square. So it is given that to cost 1 decimeter square of area, the cost is rupees 10. Now what is 1 decimeter? We are saying 10 centimeter, that is equal to 1 decimeter. It means 100 centimeter square, that is equal to 1 decimeter square. The area we have, it is 45676 centimeter square. We are saying if it is 1 centimeter square, that is equal to 1 by 100 decimeter square. So it is, this value comes out to be 4576 by 100 decimeter square. And the cost given to us for 1 decimeter square, the cost is rupees 10. For this much decimeter square, the cost will come out to be this value into 10, this much rupees. So this comes out to be 457.6 rupees. This value, it comes out to be 457.6 rupees. This is our final answer. This is the total cost that we will have. Next we have is, a gulab jamun contains sugar syrup up to about 30% of its volume. whatever the total volume of the gulab jamun is, 30% is the sugar syrup. Find approximately how much syrup would be found in 45 gulab jamuns, each shaped like cylinder with two hemispherical ends of length 5 cm and diameter 2.8 centimeters. So the length of the gulab jamun, it is given to be 5 centimeter. This is in the form of this portion, this much portion over here. This is in the form of cylinder, and we have two hemispheres on the end. These are the two hemispheres on the two ends, and the radius of these two hemispheres, it is 1.4 centimeter. So we are saying we have to calculate the volume of this. So for the volume, we are saying, suppose this length, it is h. So the volume of the two hemispheres when we are talking about, it is 2 by 3 pi r cube. This is volume of one hemisphere. There are two hemispheres, so it is 4 by 3 pi r cube, plus volume of this cylindrical portion we have. This cylindrical portion we are talking about, the volume of the cylindrical portion, it is pi r square h. So this value will become 4. So if we take pi r square common, we are left with 4 by 3 r plus h. We substitute the values in this formula. The answer we will get, it is 22 by 7 into the radius, it is given to be 1.4 into 1.4 into 4 by 3 into 1.4 plus the height that we will have, that will be equal to 5 minus 2.8, and the value comes out to be 2.2. This value of h we are saying, this comes out to be 2.2. So on solving these values, the final answer we will obtain, if we remove these decimals, it is upon 10, and this 7 2s are 14. And when you will solve all these values, you will calculate the value over here, you will get that the volume is 75.152 by 3 centimeter cube. The calculations, these are shown over here. On substituting the values, we will get the answer in this form, and the final volume for one gulab jamun, that is in equal to this. Now how many total gulab jamuns we have? It is given that there are total 45 gulab jamuns. So when we multiply this value with 45, the answer we will obtain, that is equal to 1127.28 centimeter cube. This is the volume of 45 gulab jamuns. Now it is given that 30% of it is the sugar syrup. So we are calculating 30% of this value. So it is into 30 by 100. So this is the volume of the sugar syrup that we have. So on calculating this value, we will get the answer in this value we are getting, that it is 338.184 centimeter cubes of sugar syrup in these gulab jamuns, and approximate value we have, it is 338 centimeter cube. Next is Rahul, an engineering student, prepared a model shaped like a cylinder with two cones attached to its two ends. The diameter of the model is 3 centimeter. So the radius we have over here, it is 1.5 centimeter, and its length is 12 centimeter. The total length of the model, it is given to be 12 centimeter. If each conical part has height 2 centimeter, this is the height of the conical part. So the remaining value over here for the cylinder, it is 8 centimeter. We have to find the volume of the air contained in the Rahul's model. So we are saying that the inner and outer dimensions of the model, they are almost equal, and we have also to calculate the cost of painting this model at the rate of rupees 1.50 per centimeter square. It means we have to calculate the volume first. To find the volume of the air in the model means we have to find the volume of this model. So volume of this model means there are two cylinders. We are talking about there are two cylinders, and volume of a cylinder, we know it is 1 by 3 pi. The radius for the cylinder, it is 1.5 square, and height for the cylinder, it is 2. There are two such cone we are talking about. This is the volume of the cone. So volume of the two cones will be this much. Next we are saying there is a cylinder, and the volume of this cylinder we are saying that is pi r square h. So it is pi, radius of this cylinder it is 1.5 square, and height for this cylinder it is 8. So if we take pi r square common, we will get it is pi into 1.5 square if we take common. From the first term we are left with this 4 by 3 pi. This is 2 into 2, 4, 1 by 3. Pi we have already taken common, and 1.5 square is already common. And from the second term we are left with this plus 8. So this is the volume of this complete figure or model, and this is the amount of the air that is contained in it. So on solving this we will get the answer is, it is 22 by 7 into 3 by 2 into 3 by 2 into this value comes out to be 28 by 3, and on solving this the answer we will get, it is equal to 66 centimeter cube. So this is the amount of the air in the model. Second thing we have to calculate is the cost of painting is given, it is 12.50 rupees per centimeter square. So it means we have to calculate the outer surface area. To calculate the outer surface area of this cone we have to calculate the slant height. Now this radius is 1.5 and this height is 2 centimeter. So the value of slant height will be square root of 4 plus 1.5 square, that is this 1.5 we can write it is 3 by 2 square, and it comes out to be 9 by 4, and the value comes out to be square root of 25 by 4, that is equal to 5 by 2 centimeter. This is the slant height. So the surface area for this complete figure, we are saying the lateral surface area of this cone, the formula we know, it is pi r L. How many such cones are there? There are 2 cones, and the lateral surface area of this cylinder, it is pi r 2 pi r h. H is the height over here, this 8 centimeter we are talking about. So when we substitute these values, it is 2 pi r is common, and it is h plus L. So the answer we get, it is 2 into 22 by 7. The radius we have, it is 3 by 2, and the value of h we have, it is 8, and the value of L we have, it is 5 by 2. So on substituting this value we will get, it is 2 into 22 by 7 into 3 by 2 into 21 by 2. On solving this 2 gets cancelled, it is 3 over here, and this is 11 over here. So it is 11 into 9, that is equal to 99 centimeter square. So this is the total surface area of this solid, and the cost is given to be rupees 12.5 per centimeter square. This much centimeter square is the total surface area of this solid, outer surface area we are talking about. This is the cost per square centimeter. So the total cost will be product of these two values, and on multiplying these two values the answer you will get, it is 1237.5 rupees. In these calculations, these are shown on our next slide, that this is the total cost of painting the outer surface of the model. These calculations, these are shown over here, that this is the curved surface area of the cone and curved surface area of the cylinder. It comes out to be 99 centimeter square, and the cost of painting, it is rupees 12.5 per centimeter square. So on multiplying these two values, the answer we will get, it is 1237.50 rupees. Next we have is a spherical glass vessel has a cylindrical neck 8 centimeter long. This is the 8 centimeter long cylindrical neck we have. This is 8 centimeter long, and the vessel we have, it is the spherical vessel over here, and 2 centimeter in diameter. The diameter of this neck, it is 2 centimeter. The diameter of the spherical part, it is 8.5 centimeter. By measuring the amount of water it holds, Radhika find its volume is 345 centimeter cube. Check mathematically whether she is correct taking the above as inside measurements, and pi is equal to 3.14. It means we have to calculate the volume of this solid and we have to check whether the volume comes out to be this much or not. So volume of this cylindrical portion, we have the formula, we have it is pi r square h. This is the height, this is the radius, and the volume of this spherical portion, it is 4 by 3 pi r cube. This r we are saying it will come from here, this is we are showing it is capital R. When we add both these values, the answer we will get, if we substitute the values over here, it is pi we are taking, it is common from these two, so it is 3.14 into the radius over here, it is 1 square, and height over here it is 8, plus this is the value of this first or cylindrical part, and the volume of this conical part, it is 4 by 3 into 3.14, and the radius for this portion, it is 8.5 by 2, and that is equal to 8.5 by 2, that is equal to 4.25 cube. Now multiplying these values, if we take 3.14 common, we are left with this. From the first bracket we are having, from this term we are having 8 common, from the next we are having 4 by 3 into 4.25 cube. On we have shown these calculations over here. On multiplying these values, you will get the final answer as, the final answer that you will obtain, it is 346.51 centimeter cube. This is the volume found by Radhika. We are saying it is almost correct. That is the dimensions that she has calculated over here. They are correct and they are matching with this volume. Next we have is, a juice seller was serving his customer using a glass as shown in the figure. The inner diameter of the cylindrical glass was 5 centimeter. This is given over here, that the inner diameter was 5 centimeter, and the bottom of the glass had a hemispherical raised portion. From inside, this bottom of the glass, it is raised like this. It has a raised portion over here. The inner diameter of the glass was 5 centimeter, but the bottom of the glass had a hemispherical raised portion which reduced the capacity of the glass. So now the capacity of the glass means we are talking about the fluid is in this much portion only. So the capacity is reduced by whatever the volume of this sphere is, the capacity is reduced by this much part. If the height of the glass was 10 centimeter, the height of this glass, it is 10 centimeter. Find the apparent capacity of the glass and its actual capacity. So actual capacity that we will have, it is the volume of this cylinder. So volume of the cylinder, we have formula, it is pi r square h, that is equal to, the value of pi we have to use, it is 3.14. So it is 3.14. The radius we have, it is 2.5 square, and the height we have, it is 10. On multiplying all these values, you will get the answer is 196.25 centimeter cube. So this is the actual capacity of this cylinder. We are saying how much volume is reduced by this hemispherical portion. The volume reduced by this hemispherical portion, we are saying it is 2 by 3 pi r cube. The answer comes out to be 2 by 3 into 3.14 into 5 by 2 into 5 by 2 into 5 by 2. On these calculations, these are shown over here, and on multiplying these values, the answer we will get, it is 32.71 centimeter cube. We are saying this is the volume of this spherical portion. So how much fluid will be there? Now the apparent capacity or the actual capacity we are saying of the glass will be apparent capacity, that is the volume of this complete cylinder, minus the volume of the hemispherical part. The answer comes out to be 196.25 minus 32.71, and it is equal to 163.54 centimeter cube. This is the actual capacity of the glass. The next we have is a pen stand made of wood is in the shape of a cuboid with 4 conical depressions to hold pens. The dimension of cuboids are 15 centimeter by 10 centimeter by 3.5 centimeter. So as shown in the figure, this pen stand is there and the dimensions we have it is 10 centimeter or you can say it is 15 centimeter, and the height of this stand it is given to be 3.5 centimeter. These depressions, these are given to us, their radius is given to be 1 centimeter, 1 by 2 centimeter. The radius is this, the diameter we have it is 1 centimeter diameter, and these portions we are saying these are in the form of cone. The radius we have it is 1 by 2 centimeter and the depth we have it is 1.4 centimeter. So we have to find the volume of the entire wood used in the stand. So the wood used for this cuboid, we are saying it is length into breadth into height. This is the volume of this whole cuboid, and when these portions these are taken out to keep the pen, to make it the pen stand, we have taken out these conical portions. So the volume of this conical portion, we have one conical portion we are talking about, the one volume of one conical portion, that will be 1 by 3 into pi into radius we have it is 1 by 2, it is radius square, into height that is equal to 1.4, and there are total 4 conical regions over there. So the volume, this volume of 4 conical regions that are taken out of this box, it is to be subtracted, this volume should be subtracted from this particular value. So the answers that we will get from this on solving this value, length into breadth into height, means we are talking about 10 into 15 into 3.5, the answer you will get it is 525, and on multiplying these values over here the answer we will get it is 4.4 by 3. These calculations these are shown over here, and the final answer we will get that is equal to 523.53 centimeter cube. So what we have done, we are saying we have calculated the volume of the complete box, the cuboidal box, and then we have subtracted the volume of the 4 conical depression. This 4 is there and this is the volume of the conical depressions. Next we have is a solid toy in the form of a right circular cylinder with a hemispherical shape at one end and cone at the other end. So this is the hemispherical shape on one end, this is the cone on another end, and this is the cylinder we are talking about. This is the cylinder we are saying. Their common diameter is 4.2 centimeter. So the radius over here, this will be 2.1 centimeter. The height of the cylinder and conical parts are 12 centimeter and 7 centimeter respectively. Find the volume of the given toy. So the volume of this spherical part, hemisphere we are saying, the volume of this hemisphere will be 2 by 3 pi r cube. The radius we have it is 2.1, so it is 2.1 cube. The volume of this cylindrical part we have, it will be pi r square. The radius we have it is 2.1 square, and height for this portion it is into 12, and the volume for this conical part we are saying it is 1 by 3 pi, then it is r square. R square means 2.1 square into height for this conical part it is 7. So the total volume of this figure, if we take pi common, if we take 2.1 square common, we are left with, from the first term we are left with 2 by 3 into 2.1 plus pi. From this particular we have taken pi common, we have taken 2.1 square common, then we have taken pi common, 2.1 square common, so we are left with this. From the second term we are left with this 12. From the third term we are left with this 1 by 3 into 7, this value we are left with, and on solving this value, the final answer we will get, we have to take pi is equal to 22 by 7. On solving this value, you will get the answer is, you have to calculate all these, you have to multiply these values, and you will get the answer is 218.064 centimeter cube. So this is the volume of this complete figure. The next question we have is, the largest possible sphere is caved out from a solid wooden cube of side 7 centimeter. So this is the cube given to us, and side of this cube, each side it is 7 centimeter. This side it is 7 centimeter, and the height for this it is 7 centimeter. So we have to take out a sphere. Suppose this is the sphere and the radius of the sphere, say we are saying it is r. So we have to take the largest possible sphere out of a solid wooden cube of side 7 centimeter. Find the volume of the sphere, the percentage of wood wasted in the process. So we are saying this is the volume of this wooden solid. We are saying the volume of this wooden solid will be 7 cube. So we have this wooden solid. Then what we have done, we have started removing this portion from here. We started removing this portion and we obtain this largest sphere. So the radius of this largest sphere will be half the value of this height. So it is 7 by 2 centimeter. That is the radius of this largest sphere. And the volume of this sphere will be 4 by 3 pi r cube, means 7 by 2 cube. This is the volume of this largest sphere. Now what we have to calculate? We have to calculate the volume of the sphere. So the answer we will get on solving this, these calculations, these are shown over here. It is 4 by 3 pi is 22 by 7. R cube is 7 by 2, 7 by 2 and 7 by 2. When we multiply all these values, the answer we will get, it is 539 upon 3. And the answer we are getting, it is 179.67 centimeter cube. The volume of the box we have, it is 7 cube. On solving 7 cube, we get it is 3437 centimeter cube. This is the volume of this entire wooden box. So how much is the volume of this wasted wood? It is, we are saying the values we have, it is 343 minus 539 by 3. 539 by 3 means we have already calculated this value, and this value is 179.67. We have to calculate the percentage of the wood wasted. The total amount of wood we have, how we calculate the percentage? The total wood we have, and we are calculating the amount of wood wasted. We are dividing these two values into 100, and this will give us the percentage of the wood wasted, and the answer we will get, it is, on substituting this value, we are getting this difference of these two values, that is the amount of wood wasted, it is 490 by 3. So it is 490 by 3 into 1 over total wood. The total wood we have, it is 343 into 100. This is the value we are talking about. On solving this value, the answer we obtain, it is 47 whole 13 by 21%. So this is the percentage of wood wasted in the process. Next is, from a solid right circular cylinder with height 12 centimeter. This is the cylinder given to us, it is right circular cylinder, and the height of this cylinder is 12 centimeter, and the radius of the base is 5 centimeter. The radius of its base is 5 centimeter. A right circular cone of the same height and same base radius is removed. From this cylinder, we have removed this cone. This conical portion we are saying, we have removed from this cylinder. Find the volume and total surface area of the remaining solid. So the volume of this cylinder, that is pi r square h. The volume of this cone that is removed from it, it is pi 1 by 3 pi r square h. It is 1/3 of this value. So the volume of the remaining solid, that is difference of these two, we are saying that will be 2 by 3 pi r square h. When we substitute the value, we are getting it is 2 by 3 into 20. We have to use the value of pi as 3.14 into the radius, we have it as 5. So it is 5 into 5 into height, we have it as 12. And on multiplying these values, the answer we are getting it is 628 centimeter cube. 628 centimeter cube. This is the volume of the remaining solid. Next we have to calculate is the surface area, the total surface area of this solid. So how the remaining solid will look like? We are saying the remaining solid will be, it will have this upper portion of the sphere, of this cylinder. It will have these will be the walls of that solid. Then we will have the conical portion over here. The remaining portion we will have, it is this is the upper portion, these are the walls, and then we will have the inner portion. So if we calculate the area of this circle, it is pi r square. If we calculate the lateral area of these walls, the lateral area of the cylinder, we have the value, we have it is 2 pi r h, and then we will have the area, this inside area of this conical portion. This is open from this side, so the area we will have this, and this area, that is equal to pi r l, and the value of L that we will have over here, the value of L that we will have, it will be square root of 12 square plus 5 square, and on solving this we will get it is equal to 13. So the value of L we will have it is 13. So on substituting this value, the answer we will get, it is pi r square plus 2 pi r h plus pi r l. If we take pi common, it is 3.14 common. If we take r common, the radius is common in all these values, so it is equal to 5. That what we are left with is, from the first value we are getting it is 5 plus 2 into the height of this, it is 12, plus pi into r is common, and the value of L we have it is equal to 13. So the final answer we are obtaining, it is 3.14 into 5, and then it is 2 into 12 plus 5 plus 13. On calculating this value, the final answer we will obtain, it is 659.4 centimeter square. This is the total area we will have, it is 659.4 centimeter square. This is the total area of this solid we have. Now the next question we have is, a hemispherical depression is cut out from one face of a cubical block of side 7 centimeter, such that the diameter of the hemisphere is equal to the edge of the cube. So this box is given to us, and each side of this box, it is given to be 7 centimeters. This is 7 centimeters, the height we have, and this breadth we are saying this is equal to 7 centimeters, and this hemispherical portion is cut out from this part, and it is given that the diameter of the hemisphere, it is equal to the edge of the cube. We are saying the diameter of this hemisphere is equal to edge of the cube, means the radius we have it is 7.2 centimeter. We have to find the surface area of the remaining solid. So if we look at this solid, we have 1 from this side, second from this side, third from the back side, fourth, and from the downward side we have 5 faces of this cube. We have 5 faces of cube, and if we look from the top, we are saying it is this face is there. We have, if we look at the top portion of this, it is a box over here, and from this box we are cutting out this portion of the circle. So the remaining area that we will have over here, on from the top we are talking about, it is equal to the area of this box, that is a square, area of this face, minus the area of this circular region. Area of this circular region we have, it is pi r square. After this we are saying this circular region, it is like this, it is hemisphere over here, and the area of this hemispherical region we have, that will be equal to 2 pi r square. So the total surface area that we will have, that is, we are saying the area of this whole cuboid, 5 faces we have, the area of these 5 faces is 5a square. The area of this top portion we are talking about, it is, we are saying a square minus pi r square. The radius we have, it is 7 by 2 centimeter, and the area of this third portion we have, it is 2 pi r square. So the final answer we are getting on adding these three areas, we are saying it is 6a square minus plus pi r square. So if we substitute the value, it is 6 into 7 plus 22 by 7 into radius is 7 by 2 into 7 by 2. On multiplying these values, all these values, the answer we will get, it is 294 plus 38.5, that is equal to 332.5 centimeter square. It is 332.5 centimeter square. This is the area of the remaining solid. Next we have is, a wooden article was made by scooping out a hemisphere from each end of a solid cylinder. So this is the solid cylinder that is given to us, and the hemispherical parts, these are taken out from both ends of this cylinder. If the height of the cylinder is 12 centimeter, this is 12 centimeter, and its base is of radius 4 point, the radius over here, it is 4.2 centimeter, it means this height, it is 4.2 centimeter, this height, it is 4.2 centimeter. Find the total surface area of the article. Also find the volume of the wood left in the article. Now the first thing we are going to calculate is the total surface area of this cylinder, the lateral area of this cylinder, and the formula for lateral area of this cylinder, it is 2 pi r h, and the value of h we have, it is 12 centimeter over here. This is this outer portion we are talking about, the area of this outer portion. Then we have area of the inner area of this portion over here, the inner area of this portion over here, and the inner area of this portion over here. These are the two portions we are talking about. These are two spheres we are saying, hemispheres we are saying, and two hemispheres, they together they will form the complete sphere, and the area of these two hemispheres, it will be 4 pi r square. So the total area is the sum of these two values, and the answer we will obtain, that is equal to 2 pi r is common, and we are left with this h plus 2r. On substituting the values, we are saying it is 2 into 22 by 7 into 42 by 10 into 12 plus 2 into 4.2. On solving these values, the answer we will get, it is 26.4 into 20.4, and that is equal to 53856 centimeter square. This is the total area of this article, wooden article. Second thing we have to calculate is find the volume of the wood left in the article. We have taken out these two portions. So the volume of this cylinder, we are saying it is pi r square h. H is 12, and we have taken two hemispheres. So two hemispheres means we have taken out a sphere. So the volume of this sphere, it will become 4 by 3 pi r cube. So on substituting these values in the formula, we are adding pi r square common. We are left with this h minus 4 by 3 r. So it is 22 by 7 into r square means 4.2 into 4.2 into 12 minus 4 by 3 into 4.2. This is the value shown over here. And on calculating, on multiplying these values and calculating the answers, we obtain that the total volume of the wood left in the article, that will be equal to, on solving this, you will get the answer is 354.816 centimeter cube. So this is the wood left in the article. Now the next question we have in the given figure, from a cuboidal solid metallic block of dimension, it is given 15 into 10 into 5 centimeter. This is the box that is given to us, and a cylindrical hole is made in it, and the diameter of this cylindrical hole, it is given to be 7 centimeters. We have to find the total surface area of this solid. So surface area of this solid means that we have the complete cuboid first, and the area of this cuboid, the formula we know, it is 2 times length into breadth plus breadth into height plus height into length. This is the total area of this cuboid. Now from this cuboid, if we look at this top portion of the cuboid, we have a rectangular face over here. The dimension of this rectangular face, it is 15 centimeter into 10 centimeter, and we have made a hole in this, and the diameter radius of this hole, it is 7 by 2 centimeter. So the portion that is left over here, it is this portion we are talking about. So the area, when we are calculating the surface area of this whole cuboid, it means we have considered the whole area. Now if we subtract the area of this circular portion over here, we will get the area of this region. So we are saying we are subtracting the area of this circle, and the area of this circle, it is pi into r square. This is for the top part. Similarly for this bottom part, we have similar circle over here, so we are saying it is 2 times. So this is the area we are talking about. This is the area of these 4 faces, and these top parts we are talking about, this area and this region we are talking about. This is the area of this part. Now if we look at this cylindrical portion over here, then the area of this cylindrical portion we have, that will be equal to 2 pi. The radius of this cylinder, it is given to be 7 by 2, and height of this cylinder, that will be equal to 5 centimeters. So we are saying this area is to be added. This is the inner portion of this cylinder we are talking about. This is the area of this inner portion. So on solving these values, we will get, on solving this value, the answer we will get, that is equal to, the first part when we multiply, it is 550. The second part, this 2 gets cancelled, it is 22 by 7. These two 7 get cancelled, and it is 11 over here. So we are left with this 77. Similarly for this value, if we write it is 22 by 7, these two values gets cancelled, and we are saying it is plus 110. And on calculating these values, the final surface area we get, it is 583 centimeter square. Now the next question we have is a wooden toy rocket in the shape of a cone mounted on a cylinder. It is shown in this figure. The height of the entire rocket is 26 centimeter. This is the height of the entire rocket, while the height of the conical part, it is 6 centimeters. This is the height of this conical part. The base of the conical portion has a diameter of 5 centimeter. This conical portion we are seeing, it has a base 5 centimeter, while the base of the diameter of the cylindrical portion, this portion we are talking about, it is 3 centimeter. If the conical portion is to be painted orange, this conical portion we are saying it is to be painted orange, and the cylindrical portion yellow, find the area of the rocket painted with each of these colors. So if we calculate the area of the rocket painted with the yellow cylindrical portion, we are saying it is to be painted with yellow, it means yellow is to be painted on these walls and yellow is to be painted on this circular region. So yellow color to be used, it is equal to, this is 6 centimeter, so this remaining height it is 20 centimeter. The lateral area of this cylinder, it is 2 pi r h, plus the area of this circular portion at the base, that area is pi r square. So the answer we will get, it is 2 into 22 by 7 into the radius we have, it is 3 by 2, and the height we have, it is 20, plus 22 by 7 into radius we have, it is 3 by 2 into 3 by 2. Now in this question it is given that the value of pi we have to take 3.14, so we are writing it is 3.14 over here, 3.14 over here, and when you solve these values, we take 3.14 into 3 by 2 common from both these values, so we are left with this 40 plus 3 by 2, and on solving this we will get the final answer is 781.86 by 4, and that is equal to 195.465 centimeter square. So this is for the cylindrical part, that is for the yellow color we are talking about, that this portion we are saying, this portion we have, its area is 195.465 centimeter square. The second area we have to color it with the orange color. So we are talking about this portion over here. So if we look at this portion, we have the lateral area of this cylinder. We are talking about, we will have to calculate the lateral area of this cylinder. And if we look at this bottom part over here, we have a circular region corresponding to this cylinder, and this is the circular region corresponding to the cylinder, and this is the circular region corresponding to the cone. So the area of this ring, that is to be painted orange, this ring is to be painted orange, and the area of this portion will be pi into the outer radius we have, it is 5 by 2 square, minus the inner radius we have, it is 3 by 2 square. This is 3 by 2 corresponding to the cylinder and 5 by 2 corresponding to this cone. So this is the area of this portion. The lateral area of this cylinder, the formula we have, it is pi RL. The value of L that we will have over here, when we calculate the value of L, it is square root of 6 square plus 5 by 2 square. The answer is 25 by 4 plus 36, and it comes out to be square root of 169 by 4, that is equal to 13 by 2 centimeter. So if we substitute this value over here, we are getting it is 3.14 into the radius of this cone, it is 5 by 2, and the value of L we have, it is 13 by 2 centimeters. So this is this value we are saying, this is the area of this cone, the outer area of this cone. We have this value, this is the area of this ring. So when we add both these values, these calculations, these are shown on our next slide. We are saying the value we are getting, it is pi RL plus R square minus capital R square. Small r square is the area, the radius of the cone, and capital R is the area of the radius of the cylinder. When we substitute these values, we are getting the answer in this form, and on calculating these values, on multiplying these terms, the final answer we will get, it is 63.585 centimeter square. So this is the area of the region which is to be painted with orange color, and this 195.465 centimeter square, this is the area of the region which is to be painted with yellow color. Now the next question we have is, Deepa runs an industry in a shed which is in the shape of a cuboid surmounted by a half cylinder. This is shown in the figure. The base of the shed has the dimensions. It is given that the dimensions we have, it is 7 meter, 15 meter and 8 meter. These are the dimensions of this cuboidal portion, and there is a half cut cylinder on the top of this cuboidal portion. So first thing we have to calculate is the volume of the air that this shed can hold. So volume of the air means the two portions are there. One is this half cylinder, so the area, the volume of this portion, it is 1 by 2 pi r square h. The value of h we are saying, it is height of this cylinder we are talking about. The height of this cylinder, that is equal to 15 meters. The radius of this cylinder we are saying, that is equal to 7 by 2 meters. This is the value of r we have, and this is the value of capital H we have, and the volume of this cuboidal portion we have, that is equal to length into breadth into height. This is the volume of this cuboidal portion. So if we substitute these values over here, we will get the answer. It is 1 by 2 into 22 by 7 into the value of radius we have, it is 7 by 2. So it is 7 by 2 into 7 by 2 into the height we have, that is equal to 15, plus the value of length, breadth and height we have, it is 15 into 7 into 8. On solving these values, the final answer we will obtain, that is equal to 1155 by 4 plus 840, and this value comes out to be 1128.75 meter cube. So this is the total amount of air that this shed can hold, and that is the volume of this complete shed. Next is, suppose the machinery in the shed occupies the space 300 meter square, and 20 workers are there, each of which holds the space 0.08 meter cube. So the total space occupied by these workers, that will be 20 into 0.08 meter cube. Then how much air is left in the shed? This is the total air present in the shed, and we have to subtract from it 300 plus 20 into 0.08. This value is to be subtracted, and this value comes out to be 301.6 meter cube. So when we subtract this 301.6 meter cube from 1128.75, the answer we are left with is, on subtracting these two values, the answer we are left with is 827.15 meter cube. This is the answer we are left with, 827.15 meter cube. Now the third part is, find the internal surface area of shed excluding the floor. So we have two portions over here. One is this cuboidal portions, and in this cuboidal portion we are saying, when we have to calculate the area, so we have 4 walls, and the area of those 4 walls, that will be equal to 2 times, in place of writing 2, we are saying it is 2 times length into height plus breadth into height, or we are writing it is 2h into L plus B. This is the area of the 4 walls. And the top portion we have over here, this top portion we are talking about, this is the half cylinder we are saying, this is the half cylinder we are talking about, and the area of this half cylinder, that will be equal to the area of the complete cylinder. It is the lateral, it is not the lateral area, it is the complete area we are talking about. And the formula for the complete area of this cylinder we have, it is 2 pi r into h plus r, and we are talking about it is the half cylinder, so we divide it with 2, these 2 gets cancelled. So we are saying the area of the 4 walls, the formula we have, it is 2 times h into L plus B, and the area of this half cylinder, that will be pi r into h plus r. If we are writing capital H, we must write capital H over here, it is h plus r. So the total internal area of this shed, that will be equal to, the calculations are shown on the next slide, so that will be equal to 2h into L plus B. The length, breadth and height are there. This height we are saying, this small h we are saying, it is 8 meters over here, plus the area of the cylinder, it is pi r into L plus r. So on substituting these the values in this, we will get it is 2 into 8 into L plus B, it is 7 plus 15 plus 22 by 7 into the radius that we will have over here, it is 7 by 2 into L plus R, means it is L plus R we are talking about, it is basically h plus r. The value of h we have, it is 15, and plus the value of radius we have, it is 7 by 2. So on solving these values, we will get it is 2 into 8 into 22 plus this 7 gets cancelled, this gets cancelled, we are left with this 11 into 37 by 2. And on solving this, we will get the answer is, on multiplying these terms, we will get it is 352 plus it is 11 into 37 divided by 2, and the answer comes out to be 203.5. and on adding these two values, the final answer we will get, that is equal to 555.5 meter square. And these calculations, these are also shown over here, that this is the total surface area from inside. Next question we have is, a solid is made up of a cube and a hemisphere attached on its top, as shown in the figure. Each edge of the cube measures 5 centimeter. So this is 5 centimeter, 5 centimeter and 5 centimeter. These are the length, breadth and height of this cube. And the hemisphere has a diameter of 4.2 centimeter. The hemisphere has diameter of 2.1, the radius, it is 2.1 centimeter. Find the total area to be painted. So if we are talking about the total area, so the area of this whole cube, that will be equal to 6a square. If we look at this top part, this top portion over here, we are saying it is a square over here. From this square, this portion over here, this is the hemispherical portion, so we are left with this portion only. So the area of this portion will be, to calculate the area of this portion, we are subtracting the area of this circular region. We are subtracting the area of this circular region, and the area of this circular region, it is pi into r square, means 2.1 square, and we are adding to it the area of this spherical portion. This spherical portion we are talking about, we are adding to it the area of this spherical portion, and the area of this spherical portion, it is 2 pi r square. So the final answer we are left with is 6a square plus pi r square. You can understand the same thing in the form that we have 5 faces of this cube, so it is 5a square. When we are talking about this top portion, it is, we are saying the area of this portion, it is a square minus pi r square, and the area of the hemispherical part, that is equal to 2 pi r square. So it is 2 pi r square plus 5a square plus this. When we add all these values, we will get it is 6a square plus pi r square. This is the value we are talking about. So when we substitute the values in this formula, it is 6 into 5 square plus 22 by 7 into 2.1 into 2.1. On solving this, we will get it is 150 plus 13.86, and this comes out to be 163.86 centimeter square. So this is the total area to be painted. Now the next we have is a solid toy is in the form of a hemisphere surmounted by a right circular cone of height 2 centimeter. So in this figure it is shown over here, this hemisphere is there and it is surmounted by a cone, and the diameter of base is 4 centimeter. So these are shown over here, that the diameter of the base it is, the radius it is 2 centimeter, the height of this cone it is 2. So this height is, if this radius is 2, it means this height over here, this is also 2 centimeter. If a right circular cylinder circumscribes the toy, so we are talking about this right circular cylinder over here, which circumscribes this toy. Find how much more space than the toy it will cover. So we have to calculate how much more space, means we have to calculate the area, this area we are talking about. This is the extra area it is covering than this toy. So what we have to calculate is, we have to calculate the volume of this cylinder. The formula for the volume of the cylinder, it is pi r square h. The value of r it is 2, and the height over here, that is equal to 4 centimeters for this cylinder. Next we are talking about the volume of this toy. So the volume of this toy will be volume of this hemisphere. The volume of this hemisphere, it is 2 by 3 pi r cube, plus the volume of this cone, and the volume of this cone, it is 1 by 3 pi r square h. This value of h we have, it is 2 centimeter, the height of this cylinder. So we are saying how much more volume it is occupying, it is difference of these two values. So the answer we are getting, it is pi r square into 4 minus 2 by 3 pi r cube minus 1 by 3 pi r square into 2. So on solving these values, we will get, it is the value of r square we will have, it is 4, so it is 16 pi, this is value of this term, minus the value of this term we will get, it is the value of r, it is 2, so it is 2 raised to the power 3 into 2, so it is 16 by 3 pi, minus the value of r we have, it is 2, so it is 8 by 3 pi. So this value comes out to be 16 pi minus 24 by 3 pi. So this is 8 pi. So the answer we will left is 8 pi. That is 8 into 3.14, and the answer comes out to be 25.12 centimeter cube. So this is the amount of space that the toy will cover more when it is surmounted by this right circular cylinder.